Backyard Machine Shop. Today we're working on the tailstock quill. This will be part 3 for the Pratt and Whitney lathe. And what we're going to cover in this video, we're going to cover, one, we're going to turn the quill concentric with the bores, finish turn it, and then we're going to take it over to the mill and we're going to cut a keyway in it for the fit to the tailstock. So stay tuned, hope you enjoy it. Okay, so what we're doing here is we've made a center. We took this and made this on the Monarch, and we've indicated it in here on the Kingston. And what we're about to do is we're going to make it true to the Kingston spindle to rotation. So we're within a half thousandth or so on indicating it in, but we're going to make it perfect. And the way we do that is what we've done, we've taken our compound and we've turned it to 30 degrees, and some lathes will read 30, some will read 60. This one reads 30, so we're actually turning a 60-degree compound angle. So that's 30 degrees on each side. So we're setting up our tool. I like to set the tool to where it runs square with the taper. And then it's going to hand turn this. So every time you take this out and you put it back in, you should go back and turn this taper so you'd be perfect. And this is what we're doing. I think this is regular 1018 steel. It's just something I had around. Matter of fact, it was rusty, and I've cleaned it all up. So we're running about 600 RPMs here, and it's going to come in and clean that and true that taper up. So I think we're maybe taking a 10 or 15 thousandths cut on it. Now this is an extremely big center because I'm turning between bores, and I don't need the sharp point like you do on a regular drilled center. But this still will give you a true center. And what we're trying to do is when we turn this thing, we want everything concentric with the bores. That's why I did all the boring first and roughed the spindle. So now we're setting the compound back up, and I like to keep my compound around 29 or 30 degrees. It's set up for threading, and when I need to thread, I don't have to go change it. So, and plus it keeps all the handles away from each other, and so we have the spindle. Now if you notice that I turned a little small section there. My dog wasn't quite big enough to fit the 2-inch 100, so I turned maybe 20 or 30 thousandths off of it where the dog would fit on. And we're just going to place the dog on and get it set up in between centers here. And we're just going to use one of the Chuck's jaws to drive it. And as long as you can, you can get it to fit there securely, this is a good example of how to turn it. And we're just going to tighten it up on the part now. Okay, so got it a little tight. Now you don't want it loose like this. What you need to do, what I try to do is I'll take it to the point to where it will drop by itself and it's kind of loose, and then tighten it to where I can move it, but it won't move on its own. If you get it too tight, it seems to bind sometimes. But so right now we've got it set up. We're testing to make sure we're turning. You know, everything's going to work out. Now, as this thing seats in the center and it turns for a bit, it may loosen up. So you need to go back and double check all your how tight you are. So I'm going to tighten up just a little bit. Okay. So what we're doing here is we're going to take and we're going to make a light pass just to see how everything's set up and check my speeds and get a little measurement and find out exactly where we're at and where the tool's at on the material. This is just something I like to do whenever I start turning. I like to just to make a light pass and check everything. Get it in gear. Right here, I think I'm turning 625, but I got a slow feed, so. So we measured it, and I think it was right at 2 inches 100 thousandths at that point. Because I think when we put it in there, it was like 2 inches and 125 thousandths. Alright, so what we're going to do now, we're going to make a pass and turn it completely. And our goal here is not to, we're not taking material off, we're checking our alignment with our tailstock. We don't want to turn a tapered shaft. And anytime you need precision turning over on a shaft between centers, you need to make a truing cut and then check it and see if you need to adjust your tail shaft out any tailstock, sorry. So what we're doing here is we're checking our diameter now of our spindle or our quill, and what we want the same measurement on both ends. We don't want any taper. And when I did this, if I remember correctly, we were maybe a thou and a half taper in it. So we're going to make an adjustment to the tailstock. What we're going to do is we're going to set us up an indicator on our tailstock. Now, this one, the tailstock or the quill was 1/1000 and a half smaller on the tailstock end. So we're taking and moving the tailstock over half of that amount, which would be about 7/10. And now we're going to set back up and turn it again and check it again. Now, in the last video, I did the same thing when I was roughing it, and I got it close within a few thousandths, but when the bores are boring the parts and things like that, everything changes, so you need to recheck. Alright, so we're going to come in and make a light pass, 10 thousandths or so. Like I said, we're just trying to get our tailstock dialed in. All right, we're making a light pass here, maybe 10 thousandths, trying to get our tailstock dialed in. And this is 4 times speed, so don't think we're running that fast. We're running 625 RPM, 15 thousandths speed. So it still takes a while to run 15 inches of material and at that speed. So I think we're beginning our final pass, and we're dialing into our measurement, and what we're going to do here is we're going to stop and check it and make sure where we want to be and make any adjustments if we need to make any adjustments. This is a good thing to always do when your parts, when you're trying to dial in really precision, is check your diameter the first quarter of an inch, and you can always make an adjustment. All right, so we got our So we're making our final pass, and we got it dialed in just where we want it. Within a 1/2 thousandth or so, we're going to polish out that 1/2 thousandths. Again, 4 times speed. And we're making lighter cuts. We're looking for a really good finish on this. Okay guys, so we've got it finished turned, let it cool down, getting our numbers. And we're right on where we want to be, 199 and a 1/2 thousandths. So now what we have to do is we're going to have to flip the part from end to end and put the dog on the other side and turn the part that the dog is actually bolted to right now. Alright, so we just slide it on, put the part back in between centers. And this is what turning between centers allows you to do. Alright, so we don't want to went and cut me a piece of aluminum, and that's to protect our part. We don't want to score our part up with the bolt from the dog. So you can use a penny, a piece of aluminum, anything like that, just something a little softer and tighten down on, and it keeps it from digging into your part and ruining your part. And the setup here is the same as the other. You check your fit and make sure that you're not too tight, not too loose, mainly not too loose. The cast iron's a mess. You got to constantly clean. And then this machine, when I'm done with this part, I'm gonna have to go in and vacuum and clean every inch of it because cast iron is everywhere. Okay, so we're back. So what I'm doing here is I've got some dicum, and so I need to locate where the part is. And you can use Sharpie. If I had a Sharpie handy, I probably would have used a Sharpie. I just didn't have one. But mark you enough there to see what you're doing. And we're going to come in, and we don't want to cut the material. We don't even want to touch the metal, but what we want to do is we want to remove the dicum and set our 0. So if we can turn it the right way, there we go. All right, so we're going to bring our cutter in, and we're going to go as slow as we can go. And this is something you just got to have feel for. And just turn it really slow, and you'll see the line pop up in a minute, and we know where we're at on our part. And it should pop up about now. There it is. All right, so now we're at 0. So what we do is we set our DRO to 0, or you can set your dial to 0, and we're going to come in and we're going to whittle away this material that's on this end that is excess. And we're going to do it in a couple of 3 passes. I mean, pretty much the same passes we made on the whole shaft. And what I'll do is normally you cut half of what you need, if that makes sense. Okay. So I think I just dialed into. I'm fixing to make a pass. I'm going to dial it all the way into a 1/2 thousandths off of the 0. So, and we're going to make a pass, and we'll see how that cuts our, how that references to our line that we made. And if you look at the dicum, if you're cutting too deep, the dicum will disappear, and then you can kind of tell how deep you are and what you need to go. Alright, so we dial it into 0. Again, the most we're going to be off, since we went to a 1/2 thousandths and went to 0, is within a few tenths of the right diameter. And you'll watch the dicum just disappear to the line, and there we are. So you stop the lathe, keep your hands away from it until it stops. Alright, so now you get a little feel. Can't feel anything, you're good. So move everything out of the way. Get you a piece of emery cloth, and now we're going to polish out the blend line. Just kind of blend it in with the rest of the tailstock quill. I think this is 280 grit or maybe 240 grit. Just work it until you get it all blended in where you can so we're taking our part out, and it's done. So everything should be concentric and to the bores. right size. You can see the little piece of aluminum I put in there. I'm going to take our remover dog. And clean it up a little bit. Alright, so there's our Morse taper in. Number 4 Morse, got a really good finish on the inside. You can't really see it. I'm trying to show it to you, but you can't see it. And then this end's bored for our nut. And we're going to go over and we're going to press our nut in and go over to the mill and cut. Okay, we're over at Wells Index, and we're going to cut us a key into the quill. Now, this is the original quill, and it has the keyway is 300 thousandths wide and 185 thousandths deep. Now, originally it was cut in with a horizontal mill, but I'm going to use the Wells Index to cut it. I considered doing it on the horizontal, but this machine was basically set up and go ahead and knock it out. It's 9 inches long, and we'll make short order of it. Now the purpose of the quill is, or the purpose of this keyway is to keep the quill from rotating when you run the screw in and out, and it allows it to slide up and down the tailstock bore. Okay, we need to edge find center of the quill, and the way we're going to do that is this is a standard 3/8 edge finder, and it's not quite long enough to reach down and grab the midsection of the quill. So what I have here is I have what I think is a brownish sharp. I can't remember exactly, but it's got an extended tip on it, and it's got a really fat section in it, and it's radiused. And this allows you to reach down on parts like this and get further down to where you can find that middle point. So that's what we're going to use the edge find with. So putting it in the mill, just hand tighten. So we're going to come down and we're going to find the front edge. Alright, so we got the front edge zeroed out on our DRO. We're going to run to the back side. And what I like using the half function on the DRO to do this stuff. So what you do is you edge find the front, zero, and come back, edge find the back. And get it right. You edge find the rear, and then you hit the half button on my particular DRO. All you gotta do is press the Y and a half, and it'll take you right to the center. So now we know where center is. We just come drive it back, feed back to zero on our DRO, and we're dead center. Alright, so what we're using here is we're going to use one of Dennis Nolan's Niagara cutter end mills. It's an EDP 85518. Now I use Dennis's end mills a lot at work, and I've gotten to where I'm almost solely using his for machining stainlesses and steels. Now, not so much for aluminum, but his end mills, can't remember what the name of it is. But anyway, his end mills tend to last, or Niagara's end mills tend to last a lot longer, maybe 5-10 times as long as the end mills I was using in the past. So this is a 1/4 inch, and we're basically coming in, we're finding the top of the part. And we can find the top of the part with the, we'll turn the spindle on and find the top. Alright, so now we got the spindle on, we're going to find the top of the part. Basically come up till it cuts the width of the end mill. And then we're going to go down 185 thousandths at that point. So we've got the mill set up, we're down 185 thousandths, we're on center, and we're going to start our cut. Now this is a 250 end mill, we need to go 300 wide, so we need to go, we're going to make one pass and then clean up on each side of the first pass 25 thousandths to get our 300 thousandths. Always check to make sure your end mill's not pulling out of the collet. I think we're running about 1500 RPM. Alright guys, I hope you enjoyed that, and here it is. Here's the new Quill. A couple things I've done to it off camera. One, we pressed in the nut, and the next thing is the original here's the original right here. I didn't notice this until I was trying to fit it, but this original has a flat ground into it, right about that, well, about there to there. Well, when I was trying to fit this, I couldn't get it to work. So kept checking and kept checking, and I finally seen that flat. So I've had to grind a flat in it. You can see it right here. Like I said, we've pressed the nut in and we faced it off to length. And so now it matches fine. So what we're going to do now is we're going to take and put the screw in it. And it's left-handed. So this is going to take a minute. And we're going to take it and we're going to put it into the tailstock and see how it works. Alright guys, I got you over here at the tailstock. Now this tailstock's not put together, it's just sitting out here and we're going to check the fit. So we have the handle, we have the quill, and we have the nut, the screw. So what we've done is we've got a good fit on the screw, and that screw was in good shape. The nut's brand new. So we've added a little oil to it, and we're going to slide it in. Now I'll put this in, went in and put it in because the way this thing goes together, it'd be hard to get the screw in and the quill together without it going in first. So we're just going to take and slide it in so it comes out the back. Here we go. Found the keyway. We're going to slide it in the rest of the way. Okay, we bottomed out. I'm going to walk around the table. And here's our hand wheel. I wish I'd put the handle on it, but it's not finished. So we need to do slide it on. And this originally, when it goes together, it'll have a nut back here and it'll hold it all together. So we got our retraction. We're going to retract it all the way. You know, you got a good fit. You can hear the air coming out the weep hole in the back that lets the air out. And it's got a nice fit to it. There's a little bit of play because I haven't got it tight. It's just pushing off, but yeah, can't show you that. But it's good and tight, and I don't have the lock in it to tighten it up there either. So anyway, there we have it. We have it working in the tailstock. Alright, so we're going to pull that back out. That's about it for this video. So you've seen it work. I've got a few other things to do to it, so there'll be one or two more videos, and hope you're around to watch it. So, from the Backyard Machine Shop, so long.